What do Mars rover communication failures, a radiation machine malfunction, a large-scale blackout, and everyday software problems have in common? They all have to do with software bugs related to specific parallel processing, multi-threading issues, race conditions, and deadlocks. A common saying between the practitioners looking at this phenomenon is that any sufficiently complex multi-threading software system is riddled with race conditions. In this well-publicized example referring to the Facebook IPO, Nasdaq's computer system, quote, plagued by race conditions. Within 20 minutes of its incorrect operation, mismatched prices of over 30 million shares, which resulted in over 13 million in damages that had to be paid by Nasdaq to the affected parties. This diagram explains the components of the software system developed by Thinking Software, and which we call SUM ARM, or Software Understanding Machine Applications Results Reliability Management. All of the machines on this diagram are divided in 4 categories. In the middle, you see SUM Knowledge Stations, or SUM Enterprise Edition machines. Their function is to accumulate the analysis performed elsewhere, process it, and pass it to machines subscribing for the SUM ARM service. 2. SUM-enabled production machines. 3. White box testers and developer machines, sharing their analysis with others. 4. Developer machines and technical support machines subscribing to the SUM ARM service. The communication between SUM ARM components, both within and outside of the cloud platform, is secure. We will be showing at the same time, and on one screen, using a remote desktop connection, the screens of several machines representing these 4 categories just mentioned: SUM Knowledge Station machines, development machines, production machines, and machines subscribing to the SUM ARM service. The IP addresses of the cloud provider servers are covered for security purposes. The first demo example is run on a production machine, a machine without the SUM UI. You can see that the Knowledge Station received the dynamically diagnosed race condition. Now watch how the analysis is immediately propagated to the machine subscribing to the service. The next demo is an open source application called ZoomGraph. We will run it on a developer's machine. In order to run it in SUM-enabled mode, instead of Java, we will use JTA, where JTA stands for Java Threads Analyzer. JTA is a script that invokes Java along with the SUM Java agent. The SUM Knowledge Station has demonstrated a race condition via the blinking red background on the health column corresponding to the machine running the ZoomGraph application. It has also automatically created a project with the red racing man as an icon. This project may be expanded in order to see the results of the analysis. However, we will show the analysis on the machine subscribing to the service where it was propagated. This application consists of over 3,000 classes. Pressing one key collapses the classes into packages. All this information is generated automatically and does not involve or require any IDE. However, any IDE can easily be made SUM-enabled by adding a one-line script to it, the location of the SUM Java agent, making this machine SUM-enabled. This is how a deadlock is automatically realized and analyzed by SUM. You will be notified about the occurrence of a deadlock. There is no need to watch your application performance. And like in the case of a race condition, the analysis is already performed for you. In this specific case, the issue is that the 2 methods involved in a deadlock were called with 2 parameters encoded in an incorrect order. We've demonstrated how the cloud platform environment becomes even more attractive with the application results reliability management service provided by the Software Understanding Machine, SUM ARM. Thank you.